we return back to the base case scenarios. This is the main file. In the base case scenario, we have some assumption. The PV from the capacity of the P is 0 and the capacity of wind is 0, and the network rated is in kilowatt 1450. And the first thing, we will make the load flow function, and the second thing is the reliability function. So, and after we results from the load flow and the reliability function, the result power losses and the reactive power losses and the voltage deviation, voltage stability index, and expected energy not applied, and so on, for all the outputs. And then we plot the voltage profile for each buses. This is the base case, but we will explain the function one and load flow. We start with the load flow, and after that we enter the network. After we enter the network, we also defined some parameter as accumulated power losses, accumulated reactive power, accumulated bus voltage, accumulated voltage division, and accumulated stability index, because now we try to make the load flow for all the years. So we concerned about the accumulated power losses. And after that, we also read from the Excel file the load profile for whole the system as we defined in the Excel. And after that, also we also read the load data and the line data. And after that, we started the loop for the whole years, and make the load flows. And depending on the load flow, we can make all calculated the power losses, voltage stability index, voltage power index, stability index, power stability index, and so on. And as you see here, now we defined the first thing, the first function, because before we start the load profile, this is function to define the rated network, because we don't have in the base case, we don't have PV, we don't have wind. So the main supply for this network, it is the system. It is the network, the distribution network, the transformer, or the slack bus, because we don't have a distributed generation. So now we tested if the load is the load of each hour is more than the network rating. So we applied some factors to rated or to limited the rated power. And if the network is more than the load, so now we put the factor is 1 and no limited on the network. And after that, we define some parameter like the branch, number of buses, and the base voltage, base MVA, the base impedance. And after that, we calculated for each line, for each branches, the resistance and reactance value per unit, depending on the base impedance. And after that, also we calculated the real and reactive power for each bus in the per unit. And then we start from here to the load flow. The load flow here, this is the function to arrange the buses and to classify the buses, if the PV, this PV buses or slack bus or the PQ bus. And then we, after the arrange, as you see here, until now, arrange also until classify. And this is the first equation that we use it for the load flow. After arrange the buses, the program is assumed all the voltage and the buses is 1, as you see here. This is assuming. And after we assume that, we calculated the current, the current in each buses, as you see here, from the current. and then we calculated the current branch as you see here in each line. And after we calculated the current branch as you see here, we also return backward. So that means forward, backward calculation. And after we calculated the branches, each current, dependent on the assumption of the voltage at each bus is 1. So after that, we return back to calculated the voltage at each bus. And this is the process as you see here. We repeated 5 times after to reach the value of the current in each branch and the value of voltage at each buses. And after that, after we calculated the voltage and current, now it is easy to calculate the power losses as you see here. We can calculate this is the real power loss, and this is the reactive power loss, and this is the accumulated power loss for all the system in each hour. And after that, we can also calculate the voltage stability index. And then, as you see here, we return back to the rated and multiply by base, as you see here. And then after that, now we finish the load flow for the hour, for the 1 hour, and we sum it in the accumulated variables, as you see here. This is the accumulated, and then repeated that for each hour for the whole years. And after that, to calculate the average power loss, average reactive power loss, we divided on the number of hours to calculate the average power loss, the average reactive power loss, and the average voltage stability index and the voltage deviation. And this is the output. The output will be use it in the base case function as you see here. This is the average voltage stability index. So this is the to explain a load flow program. The next video we go to the function 1, the stability function, reliability function, sorry, to explain that. Thank you very much.